So the Wellington Crafting Company, it's an e-commerce company which sells its crafts online and enable individuals to set up their own storefronts and sell their crafts on the website. So this is our aim, and we will be discussing about relational and non-relational database. So in relational database, extreme read-write capacity is not required. Strict schema rules, asset compliance is needed, and RDBMS is the best solution with least effort. Lastly, it supports for complex queries and relations. And in non-relational database, horizontal scalability is required. The data does not conform well to the traditional schemas, requiring a more flexible approach. And read-write rates surpass what traditional RDBMS can economically handle. And lastly, it supports flexible data modeling. The main difference between relational and non-relational is relational has structured tables, whereas non-relation has flexible format like key value pairs, documents, graphs. Relational uses SQL, and non-relational can handle semi-structured and unstructured data. If we talk about Amazon's relational database, there is RDS. It's best for managing structured data. And non-relational database in Amazon, it's DynamoDB. It's handling semi-structured or unstructured data. Recommendations for our company, if we use the use case one, which is the RDS, then in customer and order management, we will utilize RDS with MySQL or Postgres SQL to store customer information, order details, and statuses. For inventory tracking, we will use tables like inventory tracking, craft product IDs, warehouse codes, and available quantity. Shopping cart management employs RDS to manage cart details. Reporting and analysis leverage Amazon RDS for data warehousing, enabling complex queries. And lastly, data integrity and security are ensured through RDS built-in features like encryption, backups, and multi-availability zone deployments for a high availability. If we think about the second use case, then for session management, DynamoDB tables store session IDs, user preferences, and temporary data. Real-time analytics is also possible using DynamoDB streams, capturing clicks, page views, and purchases. It manages scalable shopping cart, ensuring high throughput and low latency. So global secondary indexes or GSI on DynamoDB tables facilitate efficient querying and indexing. If we for combination, if Wellington Crafting Company can optimize its database strategies with a combination of RDS and DynamoDB. So RDS ensures structured data management, asset compliance, and high availability through multi-availability zone deployment. And DynamoDB then adds flexibility for semi-structured data by optimizing for performance, scalability, and cost efficiency. So, Wellington Crafting Company can tailor their database solutions to specific use cases, striking a balance between the structured and flexible data management for their online marketplace. If we talk about the architectures, then we have a table called craft product, which is having category, product ID, name, size, weight, color, and price. If we want to get all the product IDs where category is, say, jewelry, then we'll get the necessary data. Similarly, we can have order table, inventory table, and cart table in our RDS. This is our architecture. So this is our user, and DNS requests to the website are handled by the Amazon Route 53, a highly available domain name system service. Cognito, which is it provides authentication, authorization, and user management features for web and mobile apps. It can be used to authenticate storefront owners and manage their user profiles, including attributes like email address, username, and custom attributes. So the online marketplace is deployed using AWS EC2 auto scaling and ELB, which is Elastic Load Balancer, to handle capacity provisioning and application health monitoring automatically. So we have CloudFront, which is a CDN, content distribution network with edge locations around the globe. It can cache static and streaming content and deliver dynamic content with low latency from locations close to the customer. Then S3 securely stores static assets related to crafts, including the product images of the crafts, manuals, and other catalog content alongside log files from microservices and clickstream information from the Amazon CloudFront. Then at the heart of the architecture is a collection of the polyglot microservices hosted in Fargate that represent domain constructs such as cart, inventory, recommendation, analytics, search, craft products, orders, users, We have RDS, which is the relational database, and DynamoDB connected. So this Amazon DynamoDB acts as a flexible, scalable backend database, efficiently managing session data like shopping carts and storing product information. So its schema-less nature enables adaptation to evolving storefront attributes and categories, ensuring optimal performance and cost efficiency. We have Elastic Cache, which is used to reduce the input output on the DynamoDB, and Elastic Search Service. It just provides fast, highly scalable search functionality. And RDS provides high availability. The order table and the databases that we saw earlier are hosted redundantly on the multi-availability zone deployment within the private subnets that are isolated from the public internet. We have Lambda, that it can be handy for implementing custom logic for storefronts, such as handling user interactions, customizing content, or processing orders. And we have simple email service that is used to send notification to storefront owners, such as the order confirmations or some customer inquiries, etc. So, cost considerations, we can see that in EC2, on-demand instances expensive as compared to reserved instances, but traffic won't be for long. So we can use on-demand based on the traffic, and we can save cost accordingly. In DynamoDB, pay as per use pricing model has been used. In Elastic Cache, the costs are dependent on the sizes and the policies. In RDS, again, on the storage and the backups and data transfer, the cost is dependent. And in CloudFront also, data transfer out and requests and regional data transfer, uh, and even in route, Amazon Route 53, the pricing is based on the hosted zones, DNS queries, and health checks. When it comes to security, again, Amazon tools provide a lot of security in each area. Like if we can say domain name system security extensions is providing security in CloudFront. There is encrypted communication. In S3, we have ACLs and bucket policies. In DynamoDB, we have encryption at rest and IAM. In Elastic Cache, we have encryption in transit and at rest. And in RDS, we also have network isolation through VPC. If we talk about the benefits, as we saw earlier, the cost efficiency is there, pay as per we use, and the scalability and flexibility, security, disaster recovery, and performance optimization is also being provided by cloud. Thank you.